Hi all, good evening. This is Abhay Mahajan and I welcome you all to this another episode of the series called Beyond Textbooks, wherein we discuss things which are not there in textbooks. So guys, I hope you're all fine and you've revised the last session wherein we did some basic questions of functional equations. Now, continuing with the same topic. So we'll continue with the same topic, that is functional equations 2. The name of the session is Functional Equations 2, wherein we'll discuss some good questions, some quality questions of this very topic. So last session we discussed very basic questions, how to, move the questions, how to take pangas with the questions of functional equations. In this session, we'll learn some different concepts of some of the questions, right? All right, so let us get started without wasting any time. This is the first question. The question is find all the functions from a set of natural numbers to a set of real numbers such that f of 1 is 3, f of 2 is 2, f of n plus 2 is 1 plus, f of 1 plus n plus 2 plus 1 upon fn is 2 for all n belonging to natural numbers. We know these two values, f of 1 is known, f of 2 is known. Let us try to find f of 3, f of 4 and so on. So if we put n is equal to 1 here, f of 3 plus 1 upon f of 1 is 2. So f of 3 is 2 minus 1 upon f of 1 and f of 1 is 3. So this comes out to be 5 upon 3. Alright, so no big deal, right? So if we try to find n is equal, put n is equal to here and try to find n is equal to f of 4. So putting n is equal to 2, f of 4 plus 1 upon f of 2 is giving me 2 as well. So f of 4 gives me 2 minus 1 upon f of 2, which is 2. And this comes out to be how much? 2 minus 1 upon 2. So this comes out to be 3 upon 2, which can be written as 6 upon 4. No problem with this. So f of 4 is 6 upon 4 as well. So can we see a pattern here? Are we seeing a pattern here? So f of 4 is 6 upon 4. F of 3 is 5 upon 2. F of 2 is given to be 2, which I can write as 4 upon 2. F of 1 is given as 3, and this can be written as 3 upon 1. So can I see a pattern? From this pattern, can I actually find the value of f of 5 without actually calculating it? So can I see by this pattern, f of 4 is 6 upon 4, f of 3 is 5 upon 3, f of 1 is 3 upon 1, f of 2 being 4 upon 2, f of 5 will be 7 upon 5, f of 6 will be 8 upon 6, and so on. So the function is f of n, because the domain is natural numbers, is n plus 2 upon n. And we can verify this. We can actually find the values of f of 5, f of 6, f of 7, and we can verify that this is the function. And the function which we found out using, the patterns of f of 1, 2, 3, and 4 is actually indeed true. Now the question is, how do we prove this mathematically? How do we prove this mathematically? Because it may be true for f of 1 or 2 or 3 or 4 or 5 or 6, but it may not be true for, let's say, f of 100. So I will have to find all the values, but I can't do so because n is a natural number, which is an infinite set. So I can't find and prove this function for all natural numbers like this way. So what is another method which is used to prove the formulas in general? Yes, so most of you guessed it. I'm talking about the principle of mathematical induction. So principle of mathematical induction is a tool to validate the formula which we have found. So we'll use the principle of mathematical induction to prove this formula, to prove this claim that f of n is n plus 2 upon n for all natural numbers. So what is principle of mathematical induction? We manually check for n is equal to 1 or 2 or 3 or 4. We prove that, we assume that it is true for some natural numbers say k, and we prove this formula for k plus 1, right? Okay, so f of n is equal to n plus 2 upon n. This is the claim, and how do we prove this? We finish the proof by using induction. How do I do this? So we have already validated for n is equal to 3 and 4. 3 और 4 के लिए हमने already check कर लिया. Let us assume that this is true for f is equal to k. Let us assume that this is true for n is equal to k. So f of k would be k plus 2 upon k. And we need to prove this for f of k plus 2. Now, f of k plus 2 would be 2 minus 1 upon f of k. And if I put this value over here, we'll get the result. You can all verify this. If I put this value, we'll get the result. F of n plus 2 will come out to be, or f of k plus 2 will come out to be k plus 4 upon k plus 2, which completes the true proof. And hence, our claim is true for all the natural numbers n. So the function is n plus 2 upon n. Right. So induction helps a lot in proving a lot of claims, which we may not be able to find easily by using normal methods. All right. So guys, let us continue and do this second question. So all the functions, find all the functions satisfying f of x plus y plus xy is equal to f of x into f of y for all xy belonging to real numbers. Now, all the functions satisfying this very. Now, all I need to do is I need to put some values, check for some values. Let's say if I put x is equal to y is equal to 0, which I think I should do for every function. Right. So x is y and 0. So f of 0 plus 0 gives me f of 0 into f of 0. So f of 0 square is f of 0. So this means either f of 0 is 0 or f of 0 is 1. So one of these two is true. इन दोनों में से कोई एक तो ट्रू है, हो सकता है दोनों ही ट्रू हो जाए. So let us check for this first. So let us check if f of 0 is equal to 0 is true. Now if f of 0 is equal to 0, what we do is we put y is equal to 0 in this equation. So we get f of x plus 0 is equal to f of x into f of 0, which is 0. So fx is equal to 0. So the function he says is f of x is equal to 0, which is false. Because this may not be true for all xy belonging to real. Because if f of x is 0, so this part is 0, this part would be 0. So it would depend on xy for LHS to be equal to RHS. When x and y both are not equal to 0, this will not be true. So this claim is false. Hence f of x is not equal to 0. And how did we reach this claim? By using this. So this means this is not true. This means f of 0 has to be 1. F of 0 is indeed 1. Alright. Now f of 0 is 1. So how do we solve further? Now again, continuing with the previous thing that we did in the previous lecture, the idea is to eliminate one of the variables. To eliminate one of the variables. Now, if I take x as 1 and y as minus 1, so x plus y would be 0 and I can use this. So if I put x as 1 and y as minus 1, so can I say f of 0, which is 1, minus 1, because x into y would be minus 1, is equal to f of 1 into f of minus 1. So we're getting two more interesting results. So this means either f of 1 is 0 or f of minus 1 is 0. ठीक है, तो जितने पंगे लेंगे उतने ज़्यादा conclusions and results आते रहेंगे functional equations में. Now, so either one of these two is true or both can be true because there's a big or in. So what if f of 1 is true? So if f of 1 is 0 and f of 0 is 1, which is we've assumed to be true, and which is true, we've proved this because this is false. Now, if f of 0 is 1, so how do we use this? How do we use this? F of 0 is equal to 1. Sorry, f of 1 is 0. How do we use this? We put y as 1 in the given equation. So if we put y as 1, we get f of x plus 1. F of x plus 1 plus x is equal to, if y is 1 and f of 1 is 0, it will be 0. So that means f of x plus 1, f of x plus 1 is minus of x. And x plus 1 can be replaced by a variable, say x, capital X. So x will be x minus 1. So that means this function would get changed to f of x is equal to minus of x minus 1 or 1 minus x. So one of the functions is f of x is equal to 1 minus x by using this statement. And similarly, likewise, if we use f of minus 1 as 0, we'll put y as minus 1 in the original equation to get the function. You can all try this and find the other function. So there will be other function also using this very condition. And that function will be y is equal to x plus 1. Y is equal to x plus 1. 1 plus x and 1 minus x. So these are the two functions which satisfy this functional equations. You can all verify this also. So f of x is 1 plus x. What will be f of x plus y? So f of x plus y would be 1 plus. जहां जहां x है वहां पे x की जगह वेरिएबल x plus y आ जाएगा. And f of y, ठीक है, so I'm verifying this. And f of y would be 1 plus y. And if I put this on the left hand side, so left hand side becomes 1 plus x plus y plus xy. And right hand side would be 1 plus x into 1 plus y, and simplifying this will give me this result only. So this is true, and likewise this would also be true, right? So this is another way of solving a functional equation. I hope you all got this. All right, so moving further, and this gets interesting now. So now we are using the concept of functional equation to prove something else. So this is a function called injective. So injective is essentially a 1-1 function. So those who know about injective function also know that how this is proved. So this is proved by using the fact that if f of x is equal to f of y implies x is equal to y only. So students who are in class 11th and 12th, they will be able to relate with this, right? For those who are studying in class 8th and 9th and 10th, they need to revise the basic of functions to understand this question better. So this is how we prove 1-1 function or injectivity of the function. Now, it is given that a function f satisfies f of m plus f of n is m plus n for all natural numbers m and n. And we need to prove that the function is injective in nature. So how do we do this? Now, the claim is, if we assume that f of m is equal to f of n, and from this we prove that m is equal to n, we are done, because this is how we prove the function is injective or 1-1. So let us assume that f of m is equal to f of n. Now if f of m is equal to f of n, can I say if I add f of n on both the sides, so f of m plus f of n is equal to f of n plus f of n. So this is there. Now m plus n, by using this, m plus n is f of m plus f of n. And if f of m is equal to f of m, I can use this. So this would be f of n plus f of n. And by definition of the function, because this is true for all natural numbers, if I put m as n here, so this would be n plus n. So m plus n is n plus n. And if I cancel these two, I get m is equal to n. And hence this has been proved. So by using f of m is equal to f of n, I have proved that m is equal to n. So indeed the function is injective in nature. So this is a simple proof, right? So for you to be able to understand this question better, you need to have a basic knowledge of functions. You need to know what are injective functions, what are surjective functions, how the functions are defined, and so on, right? Okay, so for those who are in class 12th, because this is there in class 12th NCERT books, they'll be able to relate. And for class 11, the functions is there, and you need to go through some of the extra books apart from your NCERT to be able to understand this. But the concept of injectivity and surjectivity and bijectivity are very important as far as RMO, INMO are concerned. All right. Now, which brings us to the last question of the evening. The functions from R positive to R positive satisfy the condition. So this is an interesting. F of x times f of y plus f of y times f of x is 2xy. For all xy, we need to prove that the functions are injective in nature. So all the functions that satisfy this are injective in nature. So again, we'll use the same philosophy that if f of x is equal to f of y, if we assume that f of x is equal to f of y, then x is equal to y will be true. So if we are able to prove this, x is equal to y, using f of x is equal to f of y, the assumption, we're done. This is the basic proof of injectivity, right? So how do we do this? Now, again, the two variables, try to eliminate one of them. Let us put y is equal to x. So if you put y is equal to x here, so f of x times f of x, and this would become the same. So this will be 2 is 2x square. 2 gets cancelled out. So we are left with this function, which is a relatively easy looking function as compared to the one which is given in the question. All right. So this is equal to x square. Now from this, I can also find if I put x is equal to 1. So f of 1 is 1. F of 1 is 1, right? So how do we proceed further? So can I also write, so f of x is x square and f of 1 is 1. So how do we proceed further? So if I put x as f of 1 in here, so f of 1 whole square, which is the right hand side, is f of 1 times f of 1, and f of 1 is 1. So this portion would be 1, and this would come out to be f of 1, which is 1. So that means f of 1 is 1 because the codomain is all real numbers. It cannot be minus 1. So we found this, f of 1 is equal to 1 from this. Now, if we put y is equal to 1 in the original equation, the original equation becomes f of x times f of 1, which is 1, plus f of x is 2x. So this becomes the simplified version of the original functional equation now. Now with this, we can prove that the given functional equation or given function is injective in nature. How do we do this? Now if f of x is equal to f of y, if we assume this to be true, then 2x is f of x plus f of x using this. Now f of x is f of y, and f of x would be f of y. And using again the same thing, if I put x as y, I'll get 2y. So that means x is equal to y. So assuming fx is equal to f of y, we prove that x is equal to y. And this is how we prove the functions are injective in nature. Hence, the functional equation or function represented by this functional equation is injective in nature. This is a superb question which would require a lot of practice before you are able to actually crack this. Right? So solution देख के तो हमेशा आसान लगती है चीजें, but you need to have a lot of practice. You'll be able to do these sort of questions very easily, right? All right, guys. I hope you've enjoyed the session. So we'll solve more of these questions in the next upcoming sessions. All right. So पढ़ते रहो, बढ़ते रहो, and let us achieve this dream to win gold for India. Till next time. Bye.